All right, so this is going to be the third video that you have in section 5.3. We're still dealing with special triangles. So if you can go down to where we're going to talk about an isosceles right triangle. So what you're looking at here is isosceles means that two sides are the same length. And of course, right triangle means that it has a right angle, as you can see. The legs each measure 1 unit. So then what is the measure of the two acute angles? Well, we understand that that if I've already used up 90 degrees in the triangle, then there's 90 remaining. And so each of these is going to be a 45-degree angle. And so a lot of times this is going to be called the 45, 45, 90 triangle. I'm just naming it by the angles. Now, if I were to do the Pythagorean theorem so that I could find the missing hypotenuse, then I would have 1 squared plus 1 squared is equal to c squared, or my hypotenuse squared, whatever I want to call it there. So my c squared equals 2. Take the square root of both sides, and you have that your c is equal to the square root of 2. So frequently, this is also called the 1, 1, root 2 triangle. So you can call it either by its sides or by its angles, either one. Now, if my hypotenuse is equal to 1, so right now, in this one, my hypotenuse is equal to the square root of 2. If my hypotenuse is equal to 1, then what is the value of the legs? What's the length of each of the legs? And one way to look at that is to go back to this one. What if I said, let's enlarge this triangle by multiplying all 3 sides by the value of A? Okay, so that would say that, hey, if a leg is 5, this leg is 5, and this hypotenuse is going to be 5 square root 2. Where I take the leg and I multiply by the square root of 2 to get the hypotenuse. Well, to go backwards then, if it's the leg times the square root of 2 to get the hypotenuse, then all I would need to do would be to take my hypotenuse of 1 and divide by the square root of 2 to get a leg. Of course, we will rationalize the denominator so that that leg is equal to root 2 over 2. And if that leg's equal to root 2 over 2, then I automatically know both legs are equal to root 2 over 2. So at this point then, let's translate this over to the unit circle. And I'm going to, like I did in the last video, I have a couple of pre-made triangles here that I will put on my circle. Notice that the angle here at the origin, this is 45 degrees. This is my right angle. And the hypotenuse is going to be 1 simply because we've already said that the radius is equal to 1. And so the two legs then will each equal root 2 over 2. So the coordinate then, the x value is root 2 over 2. That's my to the right value. And my upward value is also going to be root 2 over 2. These are always going to be the exact same value. And I could grab my other triangle here. We'll pull it up in the second quadrant. Again, another 45-degree angle. And once again, you'll see that I have both of the legs are the same length. So we're going to go to the left root 2 over 2, so that's going to make it a negative root 2 over 2. But then I'm going to go up the same distance, so that'll be a positive root 2 over 2. All right, so now that I have those, let's go ahead and fill in the third quadrant. Middle is going to be left root 2 over 2 and down root 2 over 2. So they're both negative. And in the last quadrant at 315 degrees, we're going to go to the right root 2 over 2, and we'll go down root 2 over 2. So for all of my middle of the quadrant positions then, I can automatically say that the coordinate is going to be root 2 over 2, root 2 over 2, and then I just have to decide where all of the positives and the negatives go. At this point now, you have all that you need for your unit circle. You've got all of the coordinates that you're going to have to learn, all of the positions, both in degrees and radians. So this is going to be something that you want to know it very, very, very well. All right, so we'll go on then. This gray box that you see here, I'm not going to fill that in because at this point you are now able to fill that in according to what we have covered already. All right, so for reference angles, a reference angle, and notice here that a reference angle is often called theta prime. A reference angle is the positive acute angle that's made by the terminal side of the angle and the x-axis. And it's always going to be between 0 and 90 if we're working with degrees, or 0 and pi over 2 if we're working with radians. All right, so let's take a look at what exactly this means. Again, notice it's the positive acute angle that's formed by the x-axis and the terminal side of my angle. So you notice 294 degrees. I've already drawn it on the x and y axis. The positive angle that's formed by the x-axis and the terminal side is this angle right in here. Okay, so then what value is that angle? Well, that is going to be 360 degrees, which is the closest x-axis is at 360 degrees, minus the 294, which is going to be 66 degrees. So my theta prime then, we would say, is 66 degrees. The reference angle is 66 degrees. All right, part B. We're looking at 883 degrees. Well, the first thing I needed to do is I needed to figure out what is coterminal to 883 degrees. So I just took 883 and I subtracted whole circles. I subtracted 360 a couple of times and found that 883 is in the exact same spot as 163 degrees. And so you see that this lands in the second quadrant. So once again, I am looking for the angle closest to the x-axis, and it's a positive acute angle. So that's going to be this angle right in here. Well, you say, well, that x-axis is at 180 degrees. So how much distance is there between 163 degrees and 180 degrees? So we'll do 180 minus 163 to get 17 degrees. The next graphic simply shows how to get that reference angle. Again, that's called theta prime. And so if your angle is in the first quadrant, then your theta and your theta prime are going to be the exact same thing. For instance, if you have a 30-degree angle, that's 30 degrees away from the x-axis. In quadrant 2, this is going to be a whole lot like this part B that we did. We're going to do 180 degrees minus my theta. In that case, it was minus 163 degrees, and that's going to give us our theta prime. If we're working in quadrant 3, now we didn't do an example of this one, but again, that closest x-axis is going to be 180 degrees. So all I will need to do is my theta subtract my 180. So think of maybe something like 210 degrees on our unit circle. If we're doing 210 degrees, how far away is 210 from 180? Well, I'm going to do 210 minus 180 to find that out to get my 30-degree reference angle. If I'm working in quadrant 4, once again, the closest angle is going to be that 360-degree angle. And so to get my reference angle, then we'll do 360 minus my theta to get my theta prime. And we did an example of that one. All right, so using these reference triangles, then we can do that with a 30, 60, 90 triangle that happens to be on our unit circle. So you'll notice we're looking at the angle of 210 degrees. We're being asked to find the exact values. Remember, this means we're not using calculators. There's no decimals in our answer. Find the exact values of the 6 trig functions of 210. The first thing that you'll want to do is you'll want to decide what your x value, your y value, and your r value is. You can choose anything you want to for your x, your y, and your r, but it's a lot easier if you work with the unit circle. So if you're working with a unit circle, then your radius is going to equal 1. The short leg is going to be a half, but notice it's going down, so it's a negative 1/2. And the long leg is going to be negative root 3 over 2. Again, negative because it's going to the left, root 3 over 2 because it's the long leg. And once I have my x, my y, and my r, it's really simple to get all of my 6 trig values. So my sine value then is going to be y over r. So that's going to be my -1/2 over 1. And then I can also easily find out what my cosecant is by taking the reciprocal. My cosine value is going to be x over r, or if you're looking at the picture, my adjacent over my hypotenuse. And so my adjacent over my hypotenuse is going to be -√3 over 2 over 1, but I don't need that over 1 anymore. To get my secant, I'll just get the reciprocal and rationalize the denominator. I did not show the work on rationalizing the denominator there. To get tangent, remember this is going to be opposite over adjacent. So this is going to be my y value over my x value. So it'll be -1/2 over -√3 over 2. Now, to be able to simplify this, first of all, neg divided by neg is pos, and then to divide fractions, you're going to multiply by the reciprocal. So I showed all of the work there at once, multiplying by the reciprocal, and then rationalizing my denominator to get √3 over 3. Cotangent then, all I really have to do is to take this version of tangent and get the reciprocal of that to get √3. For part B, it says to find the exact values of the 6 trig functions of 225. So in this case, you're going to do the same thing. It's just that you have to draw the picture yourself. So 225 degrees is smack dab in the middle of the third quadrant. Since it's smack dab in the middle, that means both of our legs are going to be √2 over 2. And since one of them is going to the left and the other is going down, they're both going to be negative. So now to get my 6 trig functions, my sine value is going to be the opposite divided by the hypotenuse. So dividing by 1 is no big deal. And then I went ahead and showed getting my cosecant as well using reciprocals. My cosine is going to end up being the exact same thing, so will my secant. And then my tangent is going to be the opposite divided by the adjacent, which is just simply going to be the value of 1. Neg over neg is still pos. And so then the cotangent is going to be the reciprocal of that. All right. Following along quite nicely then is finding trig function values using those reference angles. So there's some steps here. You want to draw a picture and you want to find a coterminal angle if it's not on the regular unit circle. You'll want to use your reference angles, your special triangles, your unit circle so that you know what your x value, your y value, and your r value are. Find your trig function values, whatever you're being asked for, and then determine what sign it is. Is it pos or is it neg? So the first thing we'll do here is look at the exact value for the sine of -150. So the first thing that I'm going to do is I just need to draw where -150 is. And you see that I already have that on my picture. This is a 30, 60, 90 triangle. So my short leg is going down. So that's going to be a -1/2 vertical y value. My long leg is going to be √3 over 2, but it's going to be negative because it's going to the left. So I now have my x value, my y value, and my r value if I'm using the unit circle, a radius of 1. The sine is going to be opposite over hypotenuse, so that's going to be a -1/2 over 1, which is just -1/2. For part B, the cotangent of 780. So the first thing I want to do, 780 is not something that I'm familiar with, so I want to get a coterminal angle. And so I'll just simply subtract a couple of whole circles, subtract 360 a couple of times, and you'll get 60 degrees as your coterminal angle. So the first thing I do is I just simply take my 60-degree angle and I put it on my picture. Again, this is a 30, 60, 90 triangle, so you have a long leg and a short leg. Both of them are positive because they're in first quadrant. Now, cotangent, remember, is not opposite over adjacent, but it's adjacent over opposite. So we're going to have 1/2 divided by √3 over 2, and we will multiply by the reciprocal and then rationalize the denominator to get √3 over 3. All right, one more before I stop this video. In example 7, notice that it says to find all the values of theta. Find all the values of theta, where theta is going to be from 0 to 360, so just on your normal unit circle, where the sine of that theta is equal to -√3 over 2. So one of the things to remember is that sine is my y value over my r value. So if I'm working on the unit circle, that r value is equal to 1. So I really only need to pay attention to the y value. And because of what we've already mentioned, root 3 over 2 is a long value. And so we're going to be looking at a negative long value. And since this is a y value, that means that we're going to be looking at y values that are going down. Going down causes them to be negative, and they are long. So this is going to occur. We're working, my directions tell me we're working in degrees. And so my long value going down is going to land me on 240 degrees in quadrant 3, but it's also going to land me at 300 degrees in quadrant 4. All right, in the next video, we'll be talking about calculator approximations. So before you start the next video, go ahead and grab your calculator.